Okay, sorry about that. All right, so number one, it's a three-part question, and it says, is it exponential? If it is it growth or decay? And then state the rate of growth and decay. This is an exponential. If your variable is an exponent, it's exponential. So that's real easy to tell. If it's exponential, you're going to have something to the xth power. Whatever else is going on doesn't really matter. You have something to the xth power. Okay? So this one is exponential. Now, is it growth or decay? That is based on the number that has the x exponent. If this number is bigger than 1, it's a growth problem. If this number that has x as the exponent, if it is less than 1, it's a decay problem. So, since this number is a 1.23, Clara, would you say it's growth or decay?
Growth.
Yep, it's a growth problem.
What page are we on again?
The very first page of your chapter 3 packet, page 24 is the number of it, but it's the very first page of the packet for chapter 3. Now, this is a growth problem. The amount that this number is either more than 1 or less than 1 is the amount of growth or decay. So since this is a growth problem, and this number is 0.23 more than 1, it's 1.23, so it's 0.23 more than 1, we have a 23% growth. So, to answer these three questions, we have several problems to do. First of all, it's exponential if it's something to the xth. Second, if this number, this is the key number right here, if that number is more than 1, it's growth. If it's less than 1, it's decay. The amount that it's less than 1 or greater than 1 is the rate. Now, the last thing says state the initial value. This other number is the initial value. So exponentials a lot of times deal with like growing populations. So in this case, we would be starting with 3 of something. That's how many we're starting with. And then this is how much we are growing by every year, every day, whatever the time is. All right, so let's look at the next one. Eli, would you say that this is indeed exponential?
Yes.
Yes, because it's something to the x. It is a number to the x. That makes it exponential. All right. Would, Miriam, would you say this is growth or decay?
Decay.
Yes. And you know it's decay, Miriam, because that number right there that I'm pointing at is less than 1. Gabe, how much less than 1 is this number?
17.
Exactly. 0.17. So this is 17% decay. The amount that you are more than 1 or less than 1 is your rate of growth or decay. And what is our initial value this time? What are we starting with? Yep. That's my initial value.
Wait, Miss Ford?
Yes.
Do we have to write it twice? Like, you know how you wrote growth and decay twice? Can we just write this, the percent and then the
Yes.
growth?
Yes, you can. You absolutely can. All right, next question. Y equals 3x squared. Is this exponential?
No.
No. Because what's the rule for exponential?
The variable's gotta be an exponent.
Exactly. It's a number to a power, or a number to a variable power, I mean. It's not a variable to a power. It's a number to a variable. So that's no, we just move on. There's no questions to ask about it. So now we've got this one. Okay. Is it exponential?
Yes.
Thank you. Growth or decay, Caroline?
Growth.
Yep. How much growth? What percent?
2%.
Yeah. Remember, however much more or less than 1 this is, that's your percent. So this is 0.02, more than 1. So this is 2% growth. And our initial value is 100. So we are starting with 100 of whatever it is we've got. This one is tricky. Anybody want to take a stab at it? It's a little bit tricky. Mary Kate, you're always good for a stab at something.
I think it's still exponential.
Actually, it's not. This is a no. Thank you for guessing no. I put you on the spot and you did it. Thank you. It's a no. And the reason it's a no is because in an exponential, you have to have a number raised to the x. You must have a number raised to the x. This is a wacky, wild equation for sure, but it is not exponential. All right, one more in this section. All right, Katie Shin, exponential?
Yeah, 8% decay.
Woo! Listen to that. It is indeed exponential, and she says it's 8% decay. She knows it's decay because this number is less than 1. How much less than 1? 0.08. So that's why she said 8% decay. Very good, Katie. And
I have a question.
And the initial value is 3.6. Yes, what's the question?
So I was wondering, what if the initial number was negative?
It won't, well, I'm going to, I can't say it can't be because it absolutely can be. But in most real life problems that we do, that will not be a negative. If it were a negative, it would just mean the initial value was negative. Now, obviously, that wouldn't be a population problem, but exponentials can be used for other things. Now, what will never be negative is this number. This number won't be negative. This number will always be a positive. But you could have a negative initial value. Okay. So now we're actually going to write some of our own exponential functions. Now, to get started, I want you to recognize that your equations, your exponential equations, have all been something times something to a power. So you have an initial value, that's your A, and then you have B, or a number, to the x. So this is the format of anything that's going to be exponential. A number times another number to the x power. Now, when I ask you to do this, I'm always going to give you 2 points, and one of the points is always going to have a 0. So I want you to get in the habit, make a little note of this, start with the point that has a 0 in it. That's going to make your life so much easier. I will always make sure you have a 0. Always make sure you start with the 0. Now, that's your x and your y. So I want you to come up to your equation and do what we've done before. We're going to plug in the y value, and we're going to plug in the x value. Now, before you start freaking out, I want you to think back to your algebra. What happens when you raise something to the 0 power?
Isn't it like 1?
It is 1. This will always be 1. Always, always, always. So what we have is 2 equals a times 1, or 2 equals a. So now we know, go back to your original equation, now we know the initial value. Now we know a is 2. So now my equation looks like this. Y equals 2 times b to the x. Because I figured out by plugging in my 0 point, I figured out that a was 2. Now what do you think I'm going to do?
Now you're going to take the second set of numbers
Exactly.
and plug in for x.
Exactly. I'm going to take the other point. I always do the 0 point first. Then I'm going to take the other point, and I'm going to put 6 in for y and 1 in for x. Sometimes we get confused and we put it in for b. Remember, this is x and y. So you're putting in 6 for y and 1 for x. Now, isn't b to the first just b? So it looks like b equals 3. So our equation is y equals 2 times 3 to the x. Because in my 2-step problem, I figured out that my a was 2 and my b was 3. Now, don't go any farther than that. Do not try to do any kind of simplification. Don't multiply these two together. This is how you have to leave your answer. They don't combine because that has an x and that doesn't. So this is it. That's the answer. Now we're going to try the next one, but before we do, does anyone have any question about either of those 2 steps there? All right, well, some of you have already started on the next one, I can see, which is awesome. I'm happy about that. Remember, this is your format, so this is what you're going to be using. So those of you that are working away there, what'd you do first? What are you doing already?
Plugging in 1/2 and 0.
Exactly. This is your x and your y. We're plugging it right in here. So 1/2 equals a times b to the 0.
Just for I
Yes.
have a question.
Yes.
Is it safe to just assume the a value each time, or is that just going to change on us and like learn something else?
It is not going to ever change. You are
So,
exactly right. So when you look at this point, if you can remember, that's going to be a every time. Because when you put in that 0 here, this is just going to turn into 1. So you're just going to have 1/2 equals a. So it is perfectly okay with me, Gabe, and everybody else, if you skip this step. You don't need to do that step if you can remember that your 0 point gives you your initial value.
Alrighty.
So that means I mean, I have all the work shown there, but you don't need to. That means that I now have an equation that looks like 1/2 b to the x, because I know that my initial value, my a, is 1/2. Okay, so Trey, what happens now? What do I do next?
You take the other point,
Mm-hmm.
plug it in there.
Yep, and the other point is 2/8. So I'm going to put 8 in for my y. There's my 1/2. There's my b, and my b is going to be squared, b squared. Now, please don't panic. That's a little bit of a complicated equation, but not hard at all. Let's multiply both sides by 2. So 16 equals b squared. And if 16 equals b squared, what is b?
4.
Yep, and square root both sides and get 4. That's exactly right. So we will write our final answer to problem number, or letter B. Our final answer will be y equals 1/2 times 4 to the x. And we do not multiply these together ever. All right. Are you guys comfortable with what Gabe was talking about? Are you comfortable with looking at problem C and saying A is 6? Would anyone like me to work through the steps to get that? It always happens that your 0 point gives you A. It's the y-intercept, it's the initial value.
Can you work it out?
Yep. So one more time. This is probably the last time I'm going to work that out because it's always exactly the same, okay? So I use this format. I put in 6 for y and 0 for x. Anything to the 0th is always going to be 1. So b to the 0th is just 1. So a is 6. That's going to happen every single time we do it. Now, the other point has a y of 3/8 and an x of 4. Now, tell me what we should be thinking about doing if we're trying to solve this equation. What do we need to do? Go ahead.
Do you times it by 4? 3.3 over 8? And then times 6 by 4?
No, I understand where you're coming from, but no. What we want to do is get rid of this 6. Okay? We need to get rid of this 6. So how do I do that? How do I get rid of the 6 over here on this side? Okay, now, since this is a fraction, instead of dividing by 6, what if I multiplied by 1/6? Would that accomplish the same thing? If I took 1/6 times 6 over 1, would that get rid of the 6? Yes. So instead of dividing, and I don't care if you divide, guys, division is fine, but this is a fraction over here, so then you're going to have to divide by a fraction. It's easier, I think, instead of dividing by 6, if we just multiply by 1/6. Now that will leave me with my b over here, my b to the fourth. This is going to go away. And now I'm going to multiply straight across, because that's how I multiply fractions. So I get 3 over 48. Does 3 over 48 reduce at all? In other words, does 3 go into 48?
No.
I think it does.
Is it 12?
16.
16. So 1/16 equals b to the fourth. Make sure when you reduce 3 over 48 that you make it 1 over 16.
You multiply it by 4 now?
I don't multiply by 4. What I do, I use the 4 though, you're on the right track. What I do is I take the 4th root, because I gotta get rid of that 4. So I'm gonna take the 4th root of both sides. It's like when you have something like this, guys, b squared equals 16, you take the square root of both sides, right? Because that's a b squared. Well, I'm doing the same thing here, only because it's b to the fourth, I'm going to take the 4th root of both sides. So now I have to figure out what the 4th root of 1/16 is. Now, you know how to do this. You guys have done this a lot when you were younger. If you take a root of a fraction, you got to take the root of the top and the root of the bottom. No matter what the root is. It's the root of the top or the root of the bottom. Well, what's any root of 1? 4th root of 1, square root of 1, 10th root of 1. What's any root of 1?
1.
Yep. So that's easy. We have a 1, that's easy. Now, what about the 4th root of 16? Remember what that means. That means,
2.
yes, it's 2. Because 2 times 2 times 2 times 2, excuse me, is 16. So the answer for B, that we were solving for B, is 1/2. So back here to my original problem, we knew y was 6, or I mean a was 6, so y equals 6 times 1/2 to the x. Now, some of you are going to be able to do that with a lot less work. I showed every single little step, and you don't have to do that. Some of you can probably do that a little more efficiently. Okay, one more. These numbers look even worse. All right, here we go. Y equals a times b to the x. What's a in my problem? Yep. So I know right from the get-go, the point with the 0 is going to give me my a, my initial value. So y equals 10 b to the x. Step 1, done. Now, 80/27 equals 10 times b to the 3rd. Please don't freak out, you guys. You are completely capable of doing this. You are trying to figure out what b is. So we got to get rid of this 10, which means what? How am I going to get rid of this 10? You've got a couple of options. We need to get rid of it. So one option is divide by 10. Another option that I like better when there's a fraction involved is to multiply by 1/10. Now, if you want to divide by 10, you guys, you absolutely can. That's going to be 80 over 27 divided by 10, which is 80 over 27 times 1/10. So you're going to end up doing exactly the same thing I'm doing, and it's perfectly okay if that makes more sense to you. So now b cubed equals 80 over 270. Multiply straight across, 80 over 270. Now what do you notice about 80 over 270?
It would be, one. I know 8 divided by 27 is 3.
Wait, can you just take out like a 10 or like a...
Yeah, we're going to reduce that fraction.
And then it's 8 over 27.
So it's 8 over 27. Yep, we're reducing the fraction. Kids, you know, if they both end in 0, you just cancel out the 10s. So it's 8 over 27. Now, 8 over 27 equals b cubed. When you're solving something to a power like that, you have to do the root on both sides. So since this is b cubed, I'm going to cube root. Just like if it's b squared, I square root. So the cube root of b cubed, that's b, but now I got to figure out, what the cube root of 8 over 27 is. And that's the cube root of 8 over the cube root of 27. And quite honestly, those are numbers you should know. You should know, as Mary Kate said, that the cube root of 8 is 2, and the cube root of 27 is 3. 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So that's my b value. Don't get excited and stop. You still have to write your equation. So your equation is y equals 10 times 2/3 to the xth power. Because we already knew the a was 10, and we just did all this work and figured out that the b is 2/3. Okay, anybody have a question about that? Okay, we're going to do just a couple of problems in the next section, and then I'll let you go. So in the next section, we are simplifying, and we are going to do it without our calculator. So this is review, but we don't do it a lot, and you might have forgotten. So let's see what we can remember in terms of 8 to the 1/3. I'm now on section 3, and I am looking at problem A, and I need to figure out what 8 to the 1/3 is. Anybody know? It's a fractional exponent.
Would it be 2?
It is 2. How did you know it was 2?
Oh, that's decay, and so
Yeah, I'm not sure. I don't quite understand that, but
well, like it's gonna be smaller because it's not a whole number.
okay, you're exactly right. What
And if you like, yeah.
what a 1/3 exponent means, kids, is a cube root. A 1/3 exponent is a cube root. Anytime you have a fractional exponent, you are going to be finding a root. This is a cube root because it's a 1/3. That's a 3. So it's a cube root. And as you said, the cube root of 8 is 2. So when I look at the next one, and it's 16 to the 1/4, a fractional exponent is a root. This is going to be a root. anytime you see a fraction as an exponent, it's a root. This one is not a cube root, it's a fourth root. Because the fraction is 1/4. Well, isn't this one also 2? Because 2 times 2 times 2 times 2, 4 2's gives me 16. So the fourth root of 16 is 2. Now, 2 more and we'll be done. 8 to the 2/3. Oh shoot, no, I guess we'll be done right now. So we'll stop right there and we'll pick up here next time. Okay, guys? Thank you and have a great day. Yes.
I just guessed what that answer was going to be.
Yep, what is your guess?
My guess was 4.
Your guess is right. Good work. You're exactly right.
Alright. Is it going to be like